Class number 14. In this class we will discuss about two main types of basic OSPF adjacencies. So let's look into this topology. So we have 5 routers R1, R2, R3, R4, R5, and all of them connected using a switch, and the interfaces facing toward the switch are all in same network. Okay, so let's say /24, and we have one network on R2 side which is 10.0.0/24, and on R3 side we have another network 192.168.0.0/24. Okay, so if we configure OSPF for all of these interfaces, let's see what happens in the adjacency side. So once you configure the network command on this interface, this interface, this interface, for this interface, this interface, and this for this interface, so basically all of them try to establish the neighborship. So in this case R2 will form neighborship with R1, R3, R5, and R4. Same thing R4 will form neighborship with R1, R3, R5. Similarly, R5 also form neighborship with R3, R1, R2, R3 is already there. So similarly, this will also try to make neighborship with all other, similarly R1. So in this way you can see there are like multiple adjacencies for each router. So whenever, for suppose let's take this R2. So R2 needs to advertise this 10.0.0 network into all other into this OSPF network. So what it will do, so for this connected network it will generate a link state advertisement. So now R2's responsibility is to send it to all other routers. So in this case it will send this link state advertisement to R1, R3, R4, and R5. Similarly, R3 will also do the same thing to advertise this network. So in real-time production you will have like multiple networks on the each router. Okay, so what will happen is whenever a router trying to send an update, it will go to all other routers. Similarly, the same thing happens for all the networks. So what this will cause is it will use most of the bandwidth just for the routing updates only. Instead of carrying the traffic from this network to this network, most of the bandwidth will be used by the routing updates. So this is not efficient. So for that purpose, in a topology like this, that means broadcast. So we have multiple routers sharing the same broadcast domain, means they are all in the same network. So instead of everyone forming the adjacency with each other and everyone sending the routing updates to everyone, the OSPF process will select one of the router in this topology as a designated router. Okay, and another router as a backup designated router. So the purpose of backup designated router is just it is backing up for the designated router. If something happens with the designated router, if for suppose if this goes down, then it will take the responsibility as the designated router. Okay, so let's see what will happen in this scenario. So in this case R2 will not form adjacency with R1 or R3. So every other router except DR and BDR, all other routers form neighborship with them. Okay, so if in case R2 will only form neighborship with R4 and R5, similarly it won't form any neighborship with R1, it won't form any neighborship with R3 as well. Okay, so R2 will only form neighborship with BDR and DR. Similarly, R3 also will form neighborship with R5 and R4, which are like DR and BDR, but it does not form any neighborship with R1 or R2. Same thing happens with R1. R1 only forms the neighborship with R4 and R5 only. Okay, and also DR and BDR also forms a neighborship. Okay, so let's see how R2 will advertise in this scenario. So R2 will advertise this network in the form of LSA packet. It will only send it to R4 and R5. Okay, and R5 will send it to all other routers in this topology. Okay, so in this case, so in this way, all non-DR, non-BDR routers will only send these LSA updates to only to the BDR and DR. Okay, and the responsibility of DR is to send the update to all other routers in the network. So this way we will reduce the routing updates in this topology. So let's see how they will advertise LSAs in this type of topology. So let's say R2 is DR other, means it's not a DR and it's not a BDR. So if it wants to send an update for this network, what it will do is it will send this LSA to address 224.0.0.6, so which is a multicast address. So multicast means sending the same information to multiple devices in the network. Okay, so in OSPF 224.0.0.6 only listening on R4 and R5. So whenever this R2 try to send a packet with this address, it will only go to DR and BDR. Okay, because when you have DR and BDR in the network in this topology, all DR other routers will send the routing updates to BDR and DR only. Okay, then DR will send that link state advertisement to all the routers in the topology using address 224.0.0.5, which is also multicast address. So this address will be listening on all the routers. Okay, so that this update will go to all the routers. So in this way we reduced sending traffic updates this way and this way. So we are not sending directly anything from R2 to R1 or R2 to R3. The update is going to DR and DR is sending to R1 and R3. Okay, so let's see how OSPF selects DR and BDR in this topology. So we have R1, R2, R3, R4 and R5, and OSPF has to choose one DR and one BDR for one segment like this. So if you want to make any router as a DR, we can configure that particular router interface with the priority, IP OSPF priority. So whatever the router interface has the highest value, that will become the DR. Okay, so if the ISPF priority value, if you configure it as 0, that particular interface for suppose if you configure ISPF priority 0 here, this particular R1 in this OSPF topology will never become a designated router. Okay, and the default value, if you don't configure any value using this command, the default value will be 1. Okay, so if you don't configure anything and with the IP OSPF priority command, the default priority they will get is 1. So if you want to make any router interface to become priority and to make it as a DR, you need to configure the highest value here. Okay, so for suppose if you are not configuring this value, all the routers will have the default value, means 1. So if all the routers having the default value, still OSPF needs to select one router as DR and another router as BDR. So what it will check is, it will check for the highest router ID. Okay, so whatever the router will have the highest router ID value, that will be selected as the DR. So in this case, if for suppose if you are giving router ID as 1.1.1, 2.2.2, 3.3.3, 4.4.4, 5.5.5. So in this topology, the highest router ID is this one, and we didn't configure any OSPF priority value, so the all having default value of 1. Okay, so this is how the DR and BDR election happens in the OSPF network. So let's look at a different topology. In this topology, so these are all under in the same area. It can be any area. So for now I am just calling it as area 1. So if you see, this is the topology that resembling the previous example. We have R1, R2 and R3, and all of them are connected to switch and they are in the same network. So when we configure the OSPF for these interfaces with the network command, so what will happen is one of the router should become the DR, another router should become the BDR, and the other one will become the DR other. Okay, so in this topology, if you don't configure any OSPF priority values, and if you are giving the router IDs like R1 is 1.1.1, this is 2.2.2, this is 3.3.3, and R4 is 4.4.4. So in this particular OSPF segment, this one will become the DR, and this will come BDR, and this will be DR other. Okay, so DR other will make neighborship with these two, and it will send LSA updates to this one and this one, and then DR will send it to everyone in this topology. So if you see, the DR, BDR, everything selection happens within this broadcast segment only. So this link is a different link. So if you configure OSPF here, this is a different network. Okay, so there is no involvement of DR, BDR and DR other compared to this one. So in this topology, we have only one link, which is two routers are directly connected with each other. So this type of link we call it as point to point. So in this, there is no way we can have another router because the end of the two physical links connected to the routers. Okay, so there is no switch and any other router involved. So to verify the status of the neighbors, we can use show IP OSPF neighbor. So now I am checking the neighborship on this one. So we can see it has neighbor with R3 and R2. If you come to the state column, you can see full this is the state. So when OSPF adjacency formed correctly, you will see the status, and after that you see the flag DR and BDR. So in this particular one, R3 is the designated router and R2 is the backup designated router. If anything happens to R3, R2 will take over the DR responsibility. Okay, so let's verify the same from R2 perspective. So if you go to R2, we can see two neighbors, one to R1 and R3. R3 we have seen it is DR. Okay, it is matching. And what is R1 in this topology? It is DR other, because it's not DR and it's not BDR, so it is DR other. So let's go and check it from the R3. So when you check from R3, BDR should be R2, okay, that's correct, and DR other should be R1, that's correct. And if you see for 4, you don't see any status because I have configured it as a point to point link. Okay, so if we have only two routers participating and they are directly connected, there is no use of selecting the DR and BDR, right? because this topology only consists only two routers. So there is no use doing all the process like selection or election of DR and BDR, sending those updates. So in this case, you can configure these OSPF as a point to point. Okay, if you don't configure anything, automatically by default OSPF will assume that it is like a BDR DR network kind of thing. Okay, so it will try to do all these election and process, but this thing is not required for this point to point link. So that's why when you verify the status from the R3 4.4.4, it's not showing anything because I configured it as a point to point link. So to configure point to point to link, we need to specify this command IP OSPF network and the network type. It is point to point, and this configuration is under the interface, not under the router OSPF configuration. Okay, so if you don't provide this command, router automatically will do the DR and BDR process. Okay, so it will select one router as DR and another as BDR. So but that is not required for this particular OSPF segment because there are only two routers participating in the OSPF. So if you go and check from the R4 standpoint, there will be only one neighborship, and that is point to point, and there is no state here because it is not participating in any DR BDR election process because we have configured the interfaces as point to point link. Okay, so to summarize, if we have broadcast, if we have routers connected with broadcast like more than 3 and 4, so we instead of like sending updates to all other, the OSPF router by default will elect the one router as the DR, another one as BDR, so that all other routers will only form neighborship and send updates to the DR and BDR, and the DR will send updates to all other routers. Okay, so that way it will reduce the routing update traffic on the topology. So if you have only two routers like this point to point, so instead of wasting resources to do all the DR and BDR process, you can simply configure the interfaces as point to point link so that routers will not perform any of these unrequired actions. Okay, so for assignment, build similar topology and verify the DR BDR status in this, and configure this link as point to point and verify the status. And in this broadcast topology, try to make R1 as a DR. By default it will choose R3, but you should try to make DR R1 as a DR. Okay, so that's all for this class.